Zona. Zona, this is for you. Quentin, this is for you. He is not here. Here. Now, let me explain here. Here, go to, this is May 3rd, Wednesday. Go to a brand new, clean page. There's not going to be any homework today. This is going to be an introduction to the next conic section. Circle's done. I'll have those tests done later today. I started them, but I'm not done. Howard, put those headphones on, please.
Do you do this too?
Now look, if you don't really pay attention, like today and tomorrow especially, you're going to be lost in space. This is more involved than the circle. I mean, the circle has a center and a radius, and boom, you got everything you need for a circle. This has a lot more. So in your notebook, your heading is this word right here. Parabola. There's your heading. Now, all you need to have here is your notebook and the study sheet I just gave you. Yeah, put on my desk. Thanks. Now, like I said, this is going to sound weird. Look at the study sheet. Look at the definition. Now, I'm going to read this, but listen to what I'm going to say. You're going to have no freaking idea what it means. None. Just bear with me. All I'm going to do today in the next 25 minutes, that's all I have, is give you an idea what this looks like and what the parts are. That's all. We'll get into problems tomorrow. A parabola is a set of points in a plane that are equidistant from a fixed line called the directrix and a fixed point not on the line called the focus point. Now, you never heard those words before. You never heard of a directrix in math. You never heard of a focus point in math. Now, like I said, a circle just has a center and a radius. This is going to have a lot more parts. Now, I guess before we even get into the curve part, in your notebook, you're going to need this. This is from algebra, freshman algebra, but you're going to need to mark this down. If you have a vertical line, and you need to write this down, the equation of a vertical line is x equals any number. I just mark this down. It's going to come up in what I'm going to show you today. In algebra, if you have a horizontal line, the equation of a horizontal line is y equals any number. Now let me just show you an example here. This is just a quick little review from freshman algebra. It's going to come up in this parabola stuff. I'll show you this right away. If I told you graph x equals 3, isn't that x equals some number? If you have x equals some number, it's a vertical line. So all you would do, x equals 3 right there, right? Is draw a vertical line through 3. This is like a little review from freshman year. You'll see where it's going to come up here shortly. See this y equals -2? That's y equals some number. That's a horizontal line. You just come down here. There's where y is -2. And you would draw that horizontal line. Okay. Now, if you're sitting there wondering, what the hell's a parabola? Now, all right, an example. Here's a good one. Let's say one country was going to fire a missile at another country. Hear me out. The way things are going in this world now. A missile or a bomb or whatever, if it's fired from the ground, travels on a parabolic path. It's all mathematics. Now, what general shape would I be talking about? I mean, look. It's going, and it's going to land somewhere else. A missile would travel on a parabolic path. What's the general shape of the curve? Andrew? Okay, an arc or a U-shaped curve. A U-shaped curve, like this. Now, on the handout there, it says all parabolas have the same general shape. See right in the middle there, it says it is a U-shaped curve which opens in one of 4 directions. There are 2 types of parabolas. Now fellas, this is all I'm going to do today. I'm just going to draw some sketches. They're not even going to be in a graph. And I just want to show you where the parts are. That's it today. I'm not going to get into any problems. I just want to give you an idea of where the parts are. Okay, 2 types of parabolas. X parabolas. Now look what I'm going to do here. X parabolas. Now, do what I'm going to do up here, but make them big enough. Don't make them real tiny, because I'm going to be putting a lot of different things on it. An X parabola is a U-shaped curve. It could open to the right, or it could open to the left. Now, watch what I'm going to do. These are just general sketches. These aren't perfect. That would be an X parabola that opens to the left. See what I mean? Opens to the left. X parabolas could open to the right. Now leave yourself some space here. Do this. These are just general sketches. That's all I'm doing today. This is a short period anyway, so that's perfect. You could have Y parabolas. Now, just make sure you're making these big enough in your notebook. A Y parabola is a U-shaped curve. It could open up, or it could open down. It says it right on the study sheet there. Watch this. Could open up, or it could open down. Now, those are just general sketches. Every problem we do, today, tomorrow, Friday, the beginning part of next week, every problem we do with a parabola has to look like one of these 4. Has to. X parabolas can go left or right. Y parabolas can go up or down. Now, when we did the circle, what was obviously the most important point? The center, right? What letters stood for the center of a circle? Now, you just took the test. What were the letters we used to stand for the center? Come on, you know this. Ethan. H and K. Okay, for parabolas, there's going to be a most important point, and we're going to use H and K. It's called the vertex point. Now, question. How about a little common sense here? If you have a U-shaped curve, I don't care which one it is, what point on a U-shaped curve would be the most important to know? Let's use common sense. I don't care if it's this one, I don't care if it's this one, I don't care if it's this one, I don't care. If you have a U-shaped curve, like any of these 4, Brandon, wake up. Thank you. What would be the most important point on a U-shaped curve? Max?
Would be the middle.
Exactly. The one where it starts the curve. Now make this a little big. Let's mark this with a capital V. Mark it with the capital V. Mark it with the capital V. Mark it with the capital V. That's called the vertex point. In fact, let me come over here. This is all going to be good stuff for you to just put in your notebook here. The parts of a parabola is somewhere away from this. All I'm doing today is showing you what all the parts look like. There are 4 parts to a parabola. A vertex, a focus, a directrix, and I know you don't know what the hell that means yet, and that's okay. Just bear with me. And an axis of symmetry. Now, if you know what's good for you, you're marking down what I'm doing here. This is all just general information. The rest of the week you're in here, you're going to hear me talking about these 4 parts of a parabola. Now, these 2 things right here are points. When I say vertex and focus, it's a point. It's an ordered pair, okay? These 2 things are lines. I'm just giving you all the general information here. So every parabola you see, there's going to be a vertex point, there's going to be a focus point, there's going to be a directrix, and there's going to be an axis of symmetry. Now, let me add one more thing. These 2, I just said they're going to be lines. They're also going to be perpendicular to each other all the time. That's real important. They're going to be lines and they're going to be perpendicular. You'll see what I mean here shortly. Okay. What's the first thing you think of when you hear the word symmetry in mathematics? Things are symmetrical. You've heard that word before, I'm sure. When you hear the word symmetry, or these things are symmetrical, or symmetric to each other, what's that mean to you? How?
They're the same.
Okay. The axis of symmetry is a line, I just said. The axis of symmetry is like a mirror. Whatever's happening on one side, same thing is happening on the other side. Now, you know where the axis of symmetry is on a U-shaped curve? It's the line that splits the U into 2 equal halves. Now, I want you to do what I'm going to do here. I want you to make it a dotted line. Watch what I'm going to do. That's the axis of symmetry. I'm just going to write the word axis here. Now, you do what I'm doing. This one. That's the axis of symmetry. This one. Axis of symmetry. This one. The axis of symmetry splits it into 2 equal halves. Everything is perfect, which means if you know a point right here, what else do you automatically know? The axis of symmetry is like a mirror. It reflects the same thing on the other side. I'm just putting that anywhere. If you know you have a point right there, where else do you know you have a point? See what I just need you to understand all this. When I start the problems tomorrow on Friday, this will make way more sense. Come on, this wasn't a hard question though. If you know there's a point right there, what other point do you automatically know? Dots.
The same spot on the other one.
Down here, right? This is like a mirror. So this is going to reflect right through, and there must be another one right there. You see what I'm saying? Perfect symmetry. So again, look, I'm going to make it a little closer. If I had one there, I had one there. It doesn't matter where it's at. If I have one here, I have one here. Here, I'll put this a little closer. If I have this one here, I have that one there. Now these could be anywhere. These are just general sketches. Okay, you need to write this down in your notebook. I'm just going to dictate it to you. Another input. Here's today's class, you guys. You're not going to know it perfect when you leave here today. That's okay. When I get into the problems tomorrow, it'll make more sense. But you need to write this down. The vertex, write this down, what I'm saying. The vertex and the focus. You got to write this down in your notebook, everybody. The vertex and the focus. You got to write this down. Abbreviate it any way you want. The vertex and the focus are always on the axis of symmetry. I'll say that again. The vertex and the focus are always on the axis of symmetry. The vertex and the focus are always on the axis of symmetry. The vertex and the focus are always on the axis of symmetry. Now, watch this. Look at the study sheet. Look at the study sheet. Go down towards the bottom. The second to last note. It says, what does it say about the focus point? Where is it located? Somebody just give it back to me. Raise your hand. Towards the bottom of the study sheet. Where does it say you'll always find the focus point? Andrew. The inside part of the curve. Now look up here. The inside part of the curve. Now, what did I just say about the vertex and the focus? They're always, David. So both of them points are always going to be on that dotted line. So if this is the vertex, where's the focus going to be? Because of what you just read to me. There's only two places it could be, to the left or to the right. Where's it got to be? Because of what I just pointed out to you in the study sheet. It's always located, give it back to me again. It's always located, Rob, on the inside part of the curve. So look, there's the curve, right? Can't be over there. It's got to be on the inside right here. So let's just put it there. Put F there. This will always be true. Here, look over here. Where's the focus? Well, it's got to be on the inside. It's got to be there. There's no units here, but go ahead.
Does the F have to, for those two parabolas, do they have to be symmetrical?
Oh yeah. These parabolas are going to be perfectly symmetrical every time. Perfect symmetry.
The F has to be on the same part and the same line.
That's what I just said. You just wrote it down. Here. Where's the focus got to be here? Above or below the vertex? Howard. Okay, and it's got to be on the inside. So put it there, mark that F. Over here, it would have to be here, below, mark that F. All right, now bear with me. I only got about 10 minutes left here. So I'm just giving you the general. Tomorrow I'm going to get right into the first kind of problem. Now, what's the only thing not up there yet? See the four parts over there? Those are the four parts of a parabola. There they are. Two of them are points, two of them are lines. What's the only thing not up there yet? Joe?
Directrix.
Okay, and I know you have no clue what that is yet. What did I tell you about the axis of symmetry and the directrix? Always. This is the first day. I don't expect you to have this all memorized yet. What did I tell you about the directrix and the axis of symmetry? They're always perpendicular. Let's go right here. For these two right here, what kind of a line will the directrix have to be? Easy question. These are easy questions, but I got to get you thinking all these relationships. It's got to be vertical because the axis of symmetry is horizontal here. All right, go to your study sheet. Right down towards the bottom. All right, this is huge. This is the biggest relationship for a parabola. The second to the last note. Look on the handout. The vertex point will always be the midpoint between the focus and the directrix. This is called the midpoint rule for a parabola. Now just look up here. Again, I'm almost done for today. The vertex will always be the midpoint between the focus and the directrix. Always. It'll split them perfectly. So here's my question to you, if you're paying attention. Where's the directrix have to be in relationship to that vertex? In what direction? The vertex will always be the midpoint between the focus and the directrix. So where will the directrix be in relationship to that V point? Just give me what direction you'd be moving. Adam? To the right. The vertex has to split them. So what kind of a line is the directrix? Vertical, right? Now, you see that distance right there? Let's go the same distance there and draw a vertical line. In your notebook, look. And mark that directrix. Where's the directrix going to be here? Just tell me where to draw it. Look, where's the directrix going to be in this sketch? Come on, these are not hard questions. I'm giving you piece by piece of this. Rob,
To the left,
it's gonna be the left here. Now, how far to the left?
the same distance.
Whatever that distance is. So I'm gonna come over here about the days, go ahead, draw another vertical line. Now let's just mark that capital D. D for directrix. Where would the directrix be in these two? What kind of a line will they be in these two y parabolas? Noah?
Horizontal.
Horizontal, right? So where am I gonna draw the horizontal line here? Just tell me where I'm gonna draw it. Howard?
Below the vertex.
Below the vertex. How far? Whatever that distance is. So look, draw. And do you see I'm making the directrix a solid line? This is how I want you to do this. The axis of symmetry will always make a dashed line. The directrix will always make a solid line, not to confuse them, so we can see it clearly. Just mark this capital D. Where's the directrix going to be in this one? Joe?
Above it.
Above it, about the same distance. Draw. Capital D. Now, take a look up here. You know, somebody said to me, are these always going to be perfectly measured? Yes. Perfect symmetry, no matter what the problem is. Look at the study sheet. I only got a few minutes left here. For all parabolas, now this vertex point over here, these are all little things that are going to come up. Would you say the vertex is the most important point on a parabola? Definitely, right? H and K are going to stand for that. Just like HK was the center of a circle, most important point, HK is going to stand for the vertex. Now, remember on the test you just took yesterday, where was the H value? It was always with what variable? Come on, you just took the test. The value of H in the circle problem, it was always with what variable? The value of H. How? Right. H was always with X, K was always with Y. Guess what? Let's go be the same here. It'll be the same here. One more thing, then I'm stopping. Third to last note. The distance from the vertex point to the focus point. You see where I'm reading? A little bit past where it says the two types. The distance from the vertex to the focus is denoted by the letter small p. Look. See this distance right here? We're going to use the letter small p to stand for it. See this distance right here? Small p. See this distance here? Small p. See this distance here? Small p. The distance from the vertex to the focus is going to be the letter lowercase p. And it says it's a directed distance. Nathan? Hang in there. It's a directed distance. You're going, well, what does that mean? Look what it says. The P is positive if it opens in a positive direction. P is negative if it opens in a negative direction. Now, wouldn't common sense tell you if it goes up, that's positive. If it goes to the right, that's positive. If it goes down, that's negative. If it goes to the left, that's negative. So you see this one here? What kind of a number would P be in this sketch? What kind of a number would this P value be in this sketch? You got no values yet. These are just sketches. What kind of a number would P be? Positive or negative? That's all I'm asking you. Dave? Negative, because it opens left. Left is a negative direction. P would be positive here. P would be positive here. P would be negative here. Joe, question? So, let me just summarize. There's no homework. Everything we do the rest of the week is going to look like one of these four. The only thing I want you, your only homework is not written. Have an idea what I'm talking about with these different parts. That's it. That was just an introduction to what we're going to get into. No homework. We'll get into the problems tomorrow. But have an idea what I'm talking about with these different parts.